It's the Life Upfront Engineering Podcast. I'm your host, Jeff Waters, covering ideas, people, and products on the cutting edge of product development. As always, join the conversation at lifeupfront.com. Today on the show, part 2 of my conversation with Jonas Latt, CEO of Flowkit, which is an innovative CFD company based near Geneva, Switzerland. A note, this discussion is part 2 of a two-parter. If you want to hear the first part, which I recommend, you can catch it. I'll have it posted at lifeupfront.com/Flowkit1. That's Flowkit and the number 1. Hey, Jonas, welcome again to the show.
Hello, Jeff.
So as a recap, you are CEO of a pretty unique CFD company, Flowkit, heavily involved in the development of this open source Lattice Boltzmann code, Palabos, which we talked a lot about on the last discussion.
Yes, exactly.
And in that discussion, we covered a lot of interesting ground around your decision to build this CAE business around open source, which I find personally kind of intriguing. Open source, as we learned, doesn't necessarily mean free, but it does come with a lot of positives. And so today I wanted to focus a little more closely on one of my personal favorites, which is CAE in the cloud. So Flowkit today builds its revenue by helping people to implement Palabos, the open source code, locally on local machines. Also customization projects. If people need it to do something that it doesn't do today, then you can help with coding and that sort of thing, correct?
Yes, that's correct. That's 100% of our revenue is currently generated by that. So
okay.
we, for example, we don't get any government resources or anything like that. So that's what everything comes from. Mm-hmm. That's correct.
That's a good point too. So currently, everything you've done to this point has been bootstrapped, correct?
Yes, that's correct. Everything is bootstrapped, and all our revenue comes from consulting services. Of course, we do get things from academia, as we talked in our previous podcast, because our academic partners help to review our code and to find errors and to validate it. But the revenue itself is not government funded at all.
Okay. So Palabos, as an open source project, didn't need a company called Flowkit to make it a reality, correct?
Well, yes and no. We did start the development of that software before having a company. But I think that the company was necessary at some point to guarantee the long-term development of the software. The development cycles of the thing is very long. 3 years are not enough. 4 years are not enough. We need something which is consistent and persistent, which you don't get in academia. So I think, yes, Flowkit was necessary to have a mature and finished project.
Okay. And when you started Flowkit, did you think of it as primarily a vehicle for continuing the development of Palabos and, the monetization of that, or developing some revenue stream around that? Or did you have this idea from the very beginning, hey, we want to put Lattice Boltzmann CFD code in the cloud as a product?
Well, no. It's difficult to say, This has gone on over so many years that I don't really remember which idea came first. But I guess that the code was there first, and then the idea to have a company to guarantee that we just can continue developing and improving this code. And as we started thinking how we could do that, well, of course, the cloud is a very natural thing to think about these days. A lot of software is in the cloud nowadays. And we just found, when we looked at the software architecture, and we will maybe talk more about that of the code, it was very natural to think about a cloud solution for Palabos. And that's why we went into that direction.
I see. Now, the types of problems that you can attack in the CFD world are some of the toughest problems out there. The problems that really require a lot of resources from traditional CFD tools. So we talked in the last episode about fluid structure interaction, heavily transient flow, multi-phase flows. These are the things that go well beyond just having, a simple flow of one kind of fluid through a duct, for example. So I am assuming that part of your drive to go to the cloud is to open up, unlimited resources for solve power.
Yes, that's correct. In CFD, you never have sufficient resources. Whenever computers become faster, people want even faster computers. It is because whatever we do is always under-resolved. We want more resolution for turbulence. We want more resolution for more physics, for multi-phase structure, for everything. That means that when you are doing CFD, you always are working with parallel computers if you can. Parallel computers are difficult to use. You have to buy them, you have to maintain them, you have to use them. You cannot be interactive with them because you submit things and you wait for results. And all these things, which are very inconvenient and very different from a desktop program, we want to circumvent them through a cloud interface, which abstracts the parallel computer from you.
Well, it also eliminates your need to go purchase a supercomputer.
That's exactly true. So in a cloud solution, you pay as you go. If you compute 1 hour, you pay for 1 hour. If you compute 2 days, you pay for 2 days.
And part of the draw here is having access, even as a small or mid-sized company or an individual providing services, is to have access to a supercomputer that might be otherwise completely out of your budget. So now that equalizes things. It gives people a lot more capability to do really high-end, large CFD jobs that might have only been possible, let's say at some of the really big automotive or aerospace companies in the past.
Yes, that's true. I think the field of CFD is a little bit more democratic when you go to a cloud solution in that sense. But it's not only that. I don't think it's only about the fact that also the small users can have big resources. And also, in the end, you need to pay for those resources in any case, no matter if they are in the cloud or at home. But I agree with you that if they are in the cloud, you don't need a big initial investment. You just can get into it with a small budget. That's correct. But I also think that even for companies which have the possibility to buy big parallel computers, cloud is the right way to go. Just because it cuts down on maintenance cost and it makes things easier to use.
Describe that a little bit more. So let's take, for example, a large automotive company that has invested in its own internal HPC supercomputer cluster. What's wrong with that? What would make a cloud-based solution better for that customer?
Well, a big budget of that company will go into maintaining that parallel cluster. And, computers every year computers are faster. You need to buy more computers. If you have a cluster, you have to renew your cluster every 4 years. Otherwise, it's obsolete. If you let it there for 10 years, your mobile phone will be faster than your cluster. So that's the problem. So you have to invest continuously, and then you have to internally put money into the systems administrator and the people who upgrade the cluster. Plus, you have to train your employees into the usage of that cluster, which very often is very technical. There is the queuing system, there is the resource management between the different users. All of this is a huge overhead, which does not cost only money, but also time of everybody, time of the managers, time of the systems administrators, and time of the users. All of this you get rid of if you go to a cloud solution. And even if you have the budget for all of this, I think in the end you're gaining if you just outsource that part of the CFD development process.
So less technician time and effort and more getting CFD results.
That's exactly that, yes.
You can use that in your marketing, by the way.
I will think about that. Thanks.
Okay. Well, so if you do have access to an unlimited supercomputer, that's not really true, but let's just say it is, in the cloud, there's another question that comes up. Well, what does that allow you to do? A lot of codes, if you're trying to attack a very large problem, and I'm talking about FEA, CFD, probably rendering, anything that you might want to do on the cloud. There is a point of diminishing returns and scalability for a lot of tools out there, and it's dependent on the code for each individual tool. So, let's say, for example, if you had 4 cores available on your local machine and you're running some simulation code, that's great. But then if you bump that up to 16 cores, you might see an increase where it's 4 times faster. That's great. But then if you go to 32 cores, maybe you don't see much of an improvement. So how does Palabos fit into scalability on the cloud?
That's a very interesting question. Yeah, scalability is the big topic. I think it's the key word you have to talk about when you talk about cloud. And I think scalability is 2 things. The first is, as you mentioned it, scalability of the application. How to do a problem faster or do a bigger problem by using more cores. And then there's a second form of scalability, and we can maybe talk about that later, which is the scalability with respect to the number of users. If you implement a cloud solution, you probably want to have 100 users this year, but maybe 10,000 users next year. So how can things be scalable with respect to the number of users? But let's start about scalability with respect to the application. It's difficult to be scalable. People who develop the CFD software or CAE software in general, they know that it's not relative to the cloud. You want your software to run on many cores, and most of the time, you want something people call strong scalability. You don't want to solve bigger problems on bigger machines. You want one given problem, a small problem, to run faster when you have many cores. So you need software which is highly scalable. So the Lattice Boltzmann method is one of the methods. Maybe let me go back a step, because we talked about the Lattice Boltzmann method in the previous podcast. But maybe I can say a few words. So that Palabos is based on that method, which is called the Lattice Boltzmann method, which does CFD in a way which is a bit different to other approaches. And one of the big advantages of that approach is scalability. So the way you can take a problem and decompose it over several computers. And usually, when people look for scalability in CFD, they have these huge machines, parallel machines available, which cost hundreds of millions of dollars, and which have this very fast network, and it's easy to be scalable on these machines. But when you talk about cloud, and we will talk about that when we talk about the scalability with respect to the number of users, you don't have a dedicated supercomputer for every user available. You want to take the general cloud resources which are available out there and which you can hire on demand, and you want to run your problem, parallelize your problem on very common, not specific resources, in which the network maybe is not optimal. It's not a fast network like on an expensive supercomputer. So scalability must be scalability of a distributed problem over resources of a slow network. So all the architecture of parallel computer and CFD applications must be rethought to work on the cloud platform, which means you cannot just take a CFD software and put it into the cloud. You have to redesign everything from scratch and think cloud from the very beginning.
And that's one of the advantages I think you have, right? Is that at least from near the very beginning, you had this idea in mind. So you've been building the code so that it is, let's call it, cloud ready.
That's right. That's the advantage we have by being a young company which started the development of that software recently. We thought about that version of distributed parallelism from the beginning, and cloud computing is there right from the beginning.
Is Lattice Boltzmann inherently easier to make parallel or make scalable than traditional Navier-Stokes approach?
There's always a huge debate over this. So whatever I say, many people will disagree with me. I think it is. I think it is inherently more parallel. It is inherently more parallel, especially when you go to this many core approach. If you go to a world where you are parallelizing not only on 100 or 1,000 CPU cores, but maybe on 1 million of them, then Lattice Boltzmann is the right way to go. Because you have control over every little small detail of your code and know how it parallelizes. I talked about that in the past podcast. When you take traditional CFD, you decompose your problem into a differential equation, a numerical analysis, and then resolution of numerical analysis. And resolution of numerical analysis, that is linear algebra. It's linear algebra on parallel computers. It's about how to, let's be honest, linear all about inversing matrices. So CFD software is always just inversing matrices on big parallel computers. But what if you have a solver which is not able to inverse your matrix on a million cores? You cannot do anything. You are stuck there, and there's nothing you can do. And in Lattice Boltzmann, you don't depend on these linear algebra solvers. You control everything from the details and think about how to distribute things on modern computers. So yes, I think it's fundamentally better for parallelism.
So one of the most talked about areas in CAE, CAD included, actually, is the cloud. A few years ago, SolidWorks, at one of their big user conferences, announced, showed a preview of something they might do in the cloud. And I was pretty excited about it, but I would say that the community, the SolidWorks community, and maybe the CAD design community as a whole, rejected that idea. A lot of people felt like this was a way for a company to do evil things, like lock them into the software they're using, own their IP, their intellectual property, and basically be able to charge whatever they felt like charging for the service, and in the long term extract more money out of customers without them having an alternative. Boy, that was a mouthful. There was a negative response. Let's just say that. Now, here a few years later, it seems to me that is thawing. That ice has been thawing, and it's rapidly thawing. What are your thoughts? What are you seeing out there, and how does that play into your plans for Flowkit?
Well, there are two answers to that question, because I think that question has two, it can be split into two topics. So the first answer is, I'm one of these people who don't believe in cloud CAD, and I will make you very sad, right? Because you believe in cloud CAD, but I will come to
You don't believe in it. Yeah. Okay. You'll have to explain.
I will come back to that. But your first question was, people have security concerns about security and trust and all of this with respect to a software which runs in the cloud. And this used to be a huge problem, and now not so much any longer. It's still a problem, but not so much. I think people are just getting used to the fact that data is in the cloud, and they're getting used to the fact that there are no more security concerns in the cloud than anywhere else. No matter if your data is on your desktop computer or on a remote computer, security must be handled properly. And this doesn't change. So you can trust the cloud just as much as you trust your desktop computer. People are getting used to that idea. Not all people, though. So it's a slow process. And this problem is the same, of course, for a CAD or CFD. I think the technical issues are exactly the same. We were talking about, and I will now maybe explain why I'm not so convinced about CAD in the cloud. The big topic for me is really scalability in the cloud. And CAD is not a problem which is fundamentally scalable, or which has traditionally be solved in a way which is scalable. If you take one of the big commercial CAD tools and run it on your desktop computer, you will see that it's not even able to use the 4 cores of your quad-core CPU. It's not scalable. It's not developed to be so.
Okay. So I misunderstood. You said that you didn't believe in CAD or CAD in the cloud. I thought you said you didn't believe in CAE in the cloud.
Oh, no. We misunderstood each other. Yes, I do believe in CAE in the cloud for many things. For FEM, for finite element analysis, I do believe in it, and also for CFD, but maybe not for CAD, not for model development. Maybe one of the things is that CAD is just running so well on a desktop computer that people don't see why they should run it on the cloud, as opposed to CFD, which does not run well on a desktop computer. It needs parallel computers. So I guess that's the big difference between the two.
Yeah, that makes a lot of sense. And I think that's maybe an important thing for the market out there to understand, is that, maybe CAD on the cloud was not received well in, let's say, around 2010. But CAE on the cloud is a very different thing and should be a different conversation.
Yes, I'm looking forward to that different conversation later on.
Okay, so what can we expect from Flowkit? So today, Flowkit is a services company specializing in helping people learn and use and customize Palabos, the open source Lattice Boltzmann CFD code. People could download that today. Let's start from that. Where can they get Flowkit, Palabos, if they want it?
So you can go to the webpage of the open source Palabos project at the address palabos.org and download the software. And
I'll have a link to that in the show notes. It's Palabos, correct?
No, it's Palabos.org. Yes,
that's right. And now I learned something new in our last conversation, which was the origin of the name Palabos. Can you explain that again? And that might help it stick in someone's mind.
So Palabos is an acronym which stands for Parallel Lattice Boltzmann Solver. That's how you can remember it. That's
so Palabos.org.
Yes.
And people can go there and download the code. What does it take to install?
Well, it takes essentially nothing because it's completely self-contained. It does not depend on other libraries. You just download it and go ahead.
And runs on Linux, Mac, PC, what platforms?
So we developed it for Linux or Mac platforms. That's where it runs best. I know that we have a big user base which uses Windows. So on the Windows, the installation is a little bit more complicated, but it's explained in the user's guide.
Okay, so you can basically use it wherever you like then.
That's correct.
All right. And, the big question, so when will we see the cloud-based version of Flowkit? And I suppose that will be the name of the product, Flowkit, based on the Palabos solvers.
That's right. Flowkit will be the name of the cloud-based product.
I noticed you sidestepped that question.
Sorry, do I?
I said I noticed you sidestepped that question. So the question was, when might we see the Flowkit product, cloud-based product available?
Oh, excuse me. So I misunderstood your question. So we will see the web-based product. Hopefully, if things go well at the end of this year. I cannot guarantee it for sure because this is software development. You never know in advance. But let's hope for it at the end of this year, 2013.
Well, I am definitely looking forward to that. And when you do release, I hope you'll come back on the show and talk a little bit more about Flowkit in the cloud.
Yes, thank you. I'm looking forward to that.
All right. Hey, thanks, Jonas. And we'll talk to you next time.
Bye, Jeff.
That's all for this episode. Thanks for listening to the Life Upfront Engineering Podcast. Visit lifeupfront.com to comment and connect with me on Twitter, Google+, and LinkedIn. Also, you can really help the show by leaving a review on iTunes. Thanks again. Until next time.